Hello everyone to this little video about the Kari QA pipeline. My name is Simon. I'm the QA engineer of Kari. And let's talk first about what's Kari. Kari is a story-driven narrative mm, combat-free adventure puzzle game, which is heavily inspired by Norse mythology. And it's a university project basically. So we have been working on this for an entire year. We have 30 people in a multidisciplinary team. I'm part of the QA team. We use Perforce as our source control tool, and therefore we are trunk-based. And the main engine we're using is Unreal Engine 4, and this enables us to deliver this project at the end. So we are currently in the release state, early access on Steam. Let's talk about the stages. So in our QA pipeline, we have the following stage. Every time a developer creates something, it needs to be reviewed. It needs to be reviewed by first other people. And in the moment you create a review via Perforce, aka Swarm, it triggers automatically a build, which will build the entire review change list, and then it will test it. It will run the basic essential tests for our gameplay, so not all tests. This is very important because all tests would take way too long because we test all functionalities, like all the quests, everything, and that would take way too long, and we don't have time to do that. That's why we have the second step, which is we run a full test analysis 3 times a day in the morning before we start working, to catch anything if anyone felt the need to commit anything after work. Then at lunchtime, in order to check if anything broke before lunchtime, and then after work at 5, in order to check if anything broke during the day. And we just run all the tests, all the extensive tests. This test unit takes about an hour to run. And then we do also twice a day a fake deployment. So the first fake deployment happens in the morning, like actually lunchtime. It's technically speaking lunchtime, so it happens at lunchtime to see if the build completely can be deployed. The only difference is we don't deploy at the end. And at the end at 5, after the tests have been run, we do also a fake deployment and see if it can be deployed. And then we do an actual deploy on a daily basis at the same time every day. Everyone knows when we deploy. And so we know exactly that this is the time we deploy. And before we actually deploy, we do the full thing. We run the build. We nativize all blueprints. We're gonna test everything extensively. And then if that's all been done, we push to Steam. And so let's talk about the tests a little bit. We have 2 types of tests. We have functionality tests, which test the pure functionality of everything. For example, does the player get damaged if something happens to the player? Or do certain aspects of the game work? Like in our case, do you drain your blessing? We have also extensively functionality tests for bugs we used to have or we encountered during the development process, and those bugs are going to be tested as well if they come back, or better not. The second part is we have quest tests. They test basically all the quests, do they work, and if they not work, we're going to fail. We're utilizing the Unreal Engine 4 automation testing tool, which you can see in this little image here. And this allows us to run the tests before people commit, so they can see, hey, does my change list actually break something? And we also run them on the server, which is very important. So you can run this also via command line, and we have an extensive library for this, and that's where we're coming next to, is our build environment. So we're using Jenkins as our continuous integration environment, and we're running it with 2 nodes. One is purely dedicated for testing, and the other one is purely dedicated for building and deployment. This is varying during the day. It's depending on the load. Like if one of the nodes is not busy, then it takes some jobs from the other one. But if this one is busy, it doesn't. So like it's prioritized which node takes what accordingly to the type of the job. In order to make this happen, I needed to modify a little bit Jenkins with my own plugin, or actually with existing plugins together in composition. The second part is we have an extensive pipeline script library because all our jobs run with pipeline script, like pipeline scripts. And we have an extensive pipeline script library which supports Unreal Engine 4 and Swarm and Mantis integration. So we can build, we can cook, we can pack, we can run tests, we can commit, we can update Swarm reviews, we can give comments to Swarm reviews, we can downvote, upvote, we can create new versions in Mantis, we can update bugs, we can remove bugs, we can add bugs. All those kind of things all can happen automatically if something goes wrong or if something triggers it. This is very helpful and helps us at the end of the cycle to do less manual labor. Now we have heard basically about the cons and the costs of the talk, and you possibly wonder what are the downsides. So let's talk about the problems. So the problems, it takes time. So every review you have need to be first manually reviewed while the build server is validating it via testing and via building. So this might take time. And depending on how many tests you run and depending on what you run and how good the server is, this might take time. So our review time takes about 15 to 20 minutes per review. So you can do simple math and you know how many we can do per hour. This might be a problem. This is especially a problem if something breaks along the line, but I'm coming to this later. The second problem is with this whole setup, because we are trunk-based. So if something breaks, aka for example the 3 tests we are running during the day to validate that nothing actually break the trunk, so the master, we need to stop. Nobody is allowed to commit anything till we have fixed this bug. This can create a little bit of a traffic jam of commits. So, and the next thing is with this, we need to guarantee that tests are working. All tests need to work. And what we have discovered or experienced in the last month while the development moved on is that when people implement new features or change features, they sometimes forget to update tests, which causes then that technically speaking, everything is fine, but the tests fail because the test expects that the old setting. So, and that's a policy problem. This needs to be clear at the beginning that everyone should run the tests locally as well. So this can be then solved with that to validate, hey, you forgot to fix the tests when you do this and this and this. And that can be a problem. Another problem is if one of the tests fails, this might be not always to all members of your team clear that it's actually a problem in the test or it's a problem in the build. So if, for example, a test fails because it's broken and people keep pushing, they might get used, like pushing reviews, they might get used to that the bot, like the build server fails, so they will ignore it. And this comes to the last point, laziness. People have the tendency to either rely completely on this. So if a review passes and stuff like this, they sometimes don't necessarily review very carefully the review because they rely on the build server to catch up bugs and those kind of things. So this needs to be clear set of policies to fix those issues. So this is what we experienced, but overall, this has solved so many problems and this has made our life at the end easier. So yeah, let's move on to the last slide because I'm actually very curious to know what you have to say about this or how you experience your QA pipeline. If you want to have a chat with me, just tweet me or DM me on Twitter, and we can have a conversation about this because I'm looking forward to hear more about this or learn more about this. Yeah, that's pretty much. Thank you very much for your time.